So this was the problem that we didn't finish yesterday in class, unfortunately. And we have a table with a bunch of ordered pairs, all generated by this equation right here. So this equation is telling us the profit, which is y, the profit that we get based on x, which is the selling price of our widget. So for example, this ordered pair, 791, if we decide to sell our widgets for $7 a piece, we would make $91 in profit. But then if we decide to sell them for $9 a piece, we would make $1,887 in profit. And it may look like the bigger the selling price, the more profit. That's true for the first several ordered pairs. But then look at here. When we set it for $23 a piece, we're making this profit, 6,619. But if we set the widget for $25 a piece, we're making less. We're making 6,175. So not as much as if we priced it at 23. And at this point on, the higher the price is, the less profit there will be. And the worst scenario, I mean, it gets worse than this, but a bad scenario is if we sell it for $35 a piece, we don't make any money at all. We lose $245. So the most natural thing in the world would be to figure out, well, what is the price? What's the special price so that I have the maximum profit here? Let me just get rid of all these white cells so we can see. We practice using what's called the intermediate value theorem, but essentially just analyzing this table. The y value, all these y values, these are all potential profits. Now, what's the biggest profit? Does it occur? I got 6,600, 6,700. So somewhere in here. It would be a mistake to think that it's just 21 because on this table it's 21, but we don't know. It could be 21.5 or it could be 22 or it could be 20, but it's somewhere in this range. So we're looking at a price between $19 per unit and $23 per unit, somewhere in that domain between 19 and 23. Well, what exactly is it? Well, I hope you realize that it's the vertex. We're trying to find the vertex of this parabola. The a value is negative, so that means my parabola is facing down. And I need to find the vertex. So that's negative b over 2a. So that's what I'm going to use here. Negative b over 2a. And for this equation, b is 1458, so that's negative 1458 divided by 2 times negative 35. And those two negatives cancel out, so it's just 1458 divided by 70. And 1458 divided by 70, I'm going to my calculator. 1458 divided by $20.83. So that's it. That's the magic number. So in between 19 and 20, $20.83 will give me the greatest profit. And it says round to the nearest dollar. So that's 21 would be the nearest dollar. But let's find out. I'm curious what the profit is. So to find that, we have the equation that tells me profit if I know the price. So negative 35. I'm going to ignore rounding it to the nearest dollar for just a second because I want to be precise. I want to type in 2083. And this is exactly how I'm going to type it into my calculator. You'll see in just a second. minus 8,400. So negative 35 parentheses 20.83 parentheses square that plus 1458 parentheses or times 20.83 parentheses minus 8,400 and enter. $6,784.03. So you see, it was really close to 21, $6,783. But if we sell it for 2083, we'd make $1 more. And $1 more is $1 more. Why not? So this was 67.84. Okay. Last problem, and then you're on your way to do the homework as best as you can. So another widget problem, and this is a function f of p. So f for function, I guess. P is the price, and f of p is the profit. So two questions here. Find out the price to maximize the profit. So again, that's negative b over 2a. And then the break-even point. Well, what is the break-even point? The break-even point would be where all the cost you need to spend to make the widget completely cancels out with all the money you bring in from selling the widgets. So basically a situation where you have zero profit. So in this scenario right here, somewhere between $33 and $35, I would make zero profit, right? I'm selling the stuff for like $34. So I'm bringing money in, but I'm also spending money to make the widget. And all the money that I'm bringing in, plus all the money that I'm spending, cancels out. And I would end up with no profit, a zero profit. So that's the break even point. So this is a 2-in-1 deal. So first, I need to find what should I sell, what should P be so that I have the maximum profit. So that's, again, negative b over 2a. And in this case, b is 51, so it's negative 50. Oh, this is going to take too long, I think. No, that was not worth it. Program, whenever I try to delete, or it freezes up and just doesn't, it makes me unhappy. So here I have my first setup. The opposite of b, so negative 51, divided by 2 times a. A is negative 1. Well, those negatives cancel out. So it's just 51 divided by 2, so that is 25.5. So I should sell, these widgets should sell for exactly $25.50. Sell the widgets for $25.50. Round to the nearest cent, which I did. And I'm just curious, what would I get if I sold it for $25.50? And so that's a matter of finding the profit. So you let P equal $25.50. And go to my calculator again. So negative parentheses. Negative parentheses. You can use a calculator on every test, even next year in Math 112, so take advantage of it. Plus 51 times 2550, parentheses, plus 206. So I get $856.25. That's how much money I would make if I sold them for $25.50. What's the break-even point? The break-even point is the price that I make no money. There's no profit. So that's when this equals 0 equals 0. And so I'm going to use the quadratic formula. Before we move on, if I set this equal to 856.25 and solve for p, do you know what I would find for p? 2550. Because when p is 2550, the result is 856.25. But I want the result to be 0. So this requires quadratic formula, unless this is factorable. I'm not sure if this is even factorable. So I'm just going to not even try to factor it. Those numbers are pretty big. And just do quadratic formula. So P equals the opposite of B. So negative 51 plus or minus square root of B squared minus 4AC. And I'm going to my calculator, B squared. So 51 squared minus 4 times A, which was negative 1, times C. All in one shot, and I get 3,425. And that equals about, well, I got negative 51 plus or minus the square root of 3425. So square root A and S will be the answer, the last answer. So the square root of 3,425 is about 58.523. So now I split it up into two numbers. Quadratic formula almost always gives me two answers. So I got negative 51. Where are you? Excellent. Come on. Plus 58.523. And that is 7.523. And I divide that by 2. So 7.523 divided by negative 2 is 376. It was negative 376. Well, that's impossible because you have to remember what P is. P is the price of this widget. So I can't sell it for, that would be like me selling you a widget and giving you $3.76 every time I wanted to sell you one. So that's totally absurd. So that's an extraneous solution. Hopefully this one gives us something that makes sense here. So let's see. I've got negative 51 minus 58.523. And then divide that by negative 2. And I get 5476. Oops. 5476. That's exactly what I should. I'm sorry. If I sell the widget for $54.76, what will happen? The profit will be 0. So that's our break-even point. We're bringing in money because we're selling them for $54.76, but all the money we're bringing in doesn't overpower the cost to make these things, and so everything just cancels out. So we're just spinning our wheels. We're not making any money.